All right, so now we are going to finish up the arithmetic geometric sequence and series chapter with geometric series. So, again, as simple as you can make it, a geometric series is a series whose terms form a geometric sequence. So, yesterday, the arithmetic sequence or series was pretty straightforward. However, geometric, we're going to have both finite and infinite series. So, these are going to be a little bit more different than the others. So again, same thing. If we look at a sequence, it's just a sequence of numbers. And if we look at the series, we take the sum of those numbers. Okay, so here's our formula that we're going to be looking at. Same things. This is our sum. This is our first term. This is our common ratio. Same thing here. And then n, of course, is our term number. Same things. Notice how this one is of a finite geometric series. So when you've been writing your notes, you might not have included the difference between the two, but you need to, especially in geometric. Okay. So go ahead and try these 4 examples like you did yesterday, where you tried 4. Start with the formula that you have, and what you don't have, you can use the formula from 2 days ago. Okay, so again, if you need to pause for more time, go ahead and do so right now. So S of 5, we're looking at our formula, which was the first term times 1 minus my common ratio, which I don't know. N, of course, is 5, and then divided by 1 minus R. So what I'm missing is my common ratio. So what I could do is use the formula from the other day. A sub n equals a sub 1 times r raised to the n minus 1. So if you notice, they've given us information about our fifth term. So if I use that, first term is 16. We don't know our common ratio, but we know that that is our fifth term. So if I take 256 and divide it by 16, 16 is equal to r to the fourth. And if I take the fourth root of 16, of course, we're going to get the 2. So then we're going to plug that into our formula. And it becomes, can you plug it into your calculator correctly? Make sure that if you are using parentheses, that you put enough parentheses around everything, that you are actually telling your calculator what you are dividing by. And we actually get 16. Now, another way to approach this is once we found our common ratio, if we wanted to, if 16 is our first term, 3, 4, 5, and 256, once I found my common ratio, what I could technically do is figure out the rest of the sequence, and then from there, all I would have to do is just add them all up. So again, this chapter can be something where you go complete common sense, or you can go complete mathematical and use actual formulas. Okay, the next one, S sub 7. We know our first term. We know our common ratio. If you notice that we are going from 8 to negative 12. We're going by some kind of fraction, so negative 3 halves. Didn't sound right. Yep. Or in other words, negative 1.5 raised to the 7th power. And I think I just realized what I did on that needs to be on the inside. So again, you notice make mistakes too. I put this 5 on the outside, so that changes things just a little bit. You notice 16 would have not have gotten us our adding up here. That should have been my first red flag. All right, so let's try that again. 16 496. That makes a whole lot more sense than just 16. All right. Just as much as y'all haven't been in school, I have not been teaching, so it takes me a little bit to get back to normal too. All right, so let's finish plugging this one in. And I ended up with $57.875. And again, in any situation, if you find yourself getting a completely different number than me and you would like to tell me that in office hours, I would be happy to look at that as well. So I'm working through the problems at the same time as y'all do. Okay. All right. So then our next problem down here at the bottom, we scroll up. There was a hidden one down there too. So if I start with S of n, this case is 5. My first term is negative 2. They give me my common ratio. And that one is as easy as it can be, plugging it in. So this one I end up with negative 3.875. And another one that you could start with negative 2, keep multiplying it by 1/2 until you get to the 5th term. So the problem in this last one is that we don't know what our n value is. We don't know what 972 is. So if I use the formula from before, 972 is equal to my first term times my common ratio, which in this case is being multiplied by 3, and then the n minus 1. So if I take my 972 and divide by 4, now we're going to get to a point in the logarithms chapter where we're going to be able to solve this without doing guess and check. But if you notice, if I keep saying 3 to the 5th power, 3 to the 4th power, 3 to the whatever power, I'm going to end up with 243. So if I say that 3 to the 5th power equals 243, then that means n must be 6. And if you notice, 1, 2, 3, 4, I wonder what this one is, and then that would be the 6th term. So if I take 108 times 3, I get 342. And if I was to multiply by 3 one more time, I'd get 972. But not every case it works out that way. So now I go back to my formula. And I can finish this problem out. And I get 1456. Okay. Again, make sure any questions that you have, you are writing those off to the side so that way you can ask them during office hours. Okay. Again, similar ideas over here. We've talked about a lot of these already. If you need to take a screenshot of that. So notice how we've done the explicit formulas, the means, graphical representation. Now we've looked at the series. We need to look at the infinite series. So we've done finite, we need infinite. Okay, so summation notation is something you probably have seen before. This big sigma sign is basically saying you're going to start plugging in from the number 2 all the way to number 5 into this formula. So if you notice, it's just the variable n. So then I plug it in, I get 2, 3, 4, 5, and then I add them together to get my answer. Something similar to that if I had n equals 1 to 3, and maybe I have 2n. That means I would do 2 times 1 plus 2 times 2 plus 2 times 3, and I would add them all together to get my answer. 6, 4, that's 10, and 2 gets me 12. So your calculator actually does all of this for you, okay? So in your calculator, and I'm hoping y'all have them on your Chromebooks. If not, hopefully you have one at home. And I thought I had one in here, and I don't. You're just going to go in to math, and there should be a summation sign there that you can enter all this in. Make sure when you're plugging this in, and you can use N or X with your calculator, that you are keeping the formula inside of the parentheses that your calculator auto generates. So go ahead and try that one in your calculator. If you're still having issues plugging that in, let me know and we'll address that during our Teams meeting. But if not, you can always do it the old school way. and you should get 75. But again, if you plug this in the calculator, you shouldn't have had any issues. So remember, go to math and then go all the way down to summation. Okay. All right, so let's look at these two examples down here. There we go. So let's look at this top one right here first. So if I notice, I am subtracting 2 each time, or adding a negative 2. So in my mind, I know this is arithmetic. So if I know I need this much information and I need a formula. So first I need to find the formula. So if I know a sub n is equal to my first term, that's n minus 1, and my common difference was that negative 2. So all of this comes back to play. That is going to be our formula. Okay, so this is our first term. We need to figure out what term number 26 is. So then easily I can take that 26, negative 26, and plug it in here. So if I take negative 26 and minus 22 from that, and then divide that by negative 2, I should get 24. So this is actually my 24th term. So I know that I need to do the 24 terms. Okay, so all of this stuff we've already learned has come back. Then you can simply find the sum of the first 24 terms by plugging that in your calculator. Same thing goes for this example down here. If you have any issues with that one, please let me know. Again, more examples of plugging in the calculator. Make sure on this one, even though there's already parentheses, that these go around. Those are the ones that are automatically populated for you. Again, more examples. Okay, so like I said, finite, we have a stopping point. That doesn't mean we can't keep going. It's just the sequence itself stops, okay? Infinite is going to be that dot, dot, dot off to the side, okay? Finite, infinite. It's just going to keep going. Even though nothing's stopping me from continuing this on, I'm just saying if I ask you the question, the sum of the first 5 terms, I'm specific. But if I'm asking you the sum of the sequence and it's infinite and it keeps going, then I want to know what that means. So this is where it gets a little different. So an infinite geometric series, okay, or common ratio, the absolute value of it, that's huge, is less than 1. Then it's going to have a sum. But if my common ratio is greater than or equal to 1, it does not have a sum. So I always like to say, if it is, we're going to get to the words here in a second on the next slide. Okay, so these are the words I'm talking about, converge and diverge. All right, so if a series converges, then our common ratio is less than 1. So I always say converge means I can have a sum. Okay, but if it is greater than or equal to 1, then it does not have a sum, which means it diverges. So does not have a sum. So So when you answer these questions, you're going to first tell me if it converges or diverges, and then from there, you're going to tell me if it has a sum. If it does, you're going to give it to me. If it doesn't have a sum, you're just going to say it does not have a sum. So again, make sure you're filling that in. If you need to pause. Okay, so really what we need to figure out is what our common ratio is. Okay, so if I look at the first one, I notice that I am multiplying by negative 1/6. So if I take the absolute value of that, I get 1/6. Is that greater than or equal to 1 or less than 1? It is less than 1. So this series actually converges to a specific number. Even though it keeps going on forever, it converges to an actual number. Okay? And we'll go over how to find the sum on the next slide. Okay? The next one, and remember, if we're not sure, we can always take the second term and divide it by the first term and so on to figure out what is being multiplied. Okay, so in this particular one, our common ratio is 2, which means it diverges and it does not have a sum. So I'm actually going to put no sum. Okay. So what does it mean when it does converge? How do I find the sum? It's probably, and I don't have it up there, and there it is. It is the smallest formula you'll have to remember. The first term over 1 minus r. So let's go back to that one. Our first term is 1 over 1 minus my common ratio. Now be careful here because it is the actual common ratio, not the absolute value. So we should get 6/7. If you keep going on forever with that, it will actually converge as close as it can to that 6/7. It's really weird how that works. Okay. Same thing for these problems, but notice how down here, there's no infinity button in your calculator. So we need to figure out our common ratio. Well, if I was to plug in 1, I'd get 0.8. If I was to plug in 2, I'd get 0.64. Well, if you notice, our common ratio is that 0.8, which is less than 1. So then we would say that it converges. And we would do 1, oh wait, a sub 1, which is 0.8, over 1 minus my common ratio. And then I'd be able to solve from there. Okay, so these problems are pretty straightforward. However, they're more than what we've been doing, and that's why they can be a little bit more tricky. Okay? Make sure you're trying any other examples we don't do, and then if you have any questions on those, please let me know. Okay, so we should be at our homework by now. Again, go ahead and finish all of your homework. Make sure it's all turned in. We will review tomorrow and test the next day. Have a good day.